Tableau is an industry-leading desktop or cloud-based interactive business intelligence tool that centers on visualization, dashboarding, and data discovery. In past versions of Analytics Solver, users have only been able to upload their model parameters, or their model data, to Tableau after solving an optimization or simulation model. However, starting with version 2018, Analytics Solver now includes the ability to turn your Excel-based optimization or simulation model into a Tableau extension. That is, your full optimization or simulation model ready to accept Tableau data, run on demand on the web using our RACON server, and display visual results within Tableau. In order to use this new feature in Analytics Solver version 2018, you must first install Tableau version 2018.2 or later. For more information on this business intelligence tool, please see the following website. In this video, we will create a Tableau extension using the Troupe rotation optimization example model. To open this model, click Help, Examples, Optimization Examples, and then scroll down to Troupe rotation. This example model determines how Army troops should be moved to minimize costs. The optimization model is included in the Model tab of the Solver task pane. This model, written in algebraic form, is shown on screen. The engine selected to solve this model is the standard LP quadratic engine as shown on the Engine tab in the Solver task pane. This is the engine that will be used to solve the model within Tableau. In past versions of Analytics Solver, you only had the option of uploading your final solution values, meaning your final variable, constraint, and objective values to Tableau. As a result, anytime there was a change to the model had to be solved in Excel first, and then the data could be uploaded back to Tableau. As I said before, in 2018, all of this has changed. Now, we can change our model parameters and resolve our model within Tableau without ever having to go back to Excel. To start, we will use the PSI data source function to flag or specify the parameters in the Excel model that we would like the ability to edit from within Tableau. Select a blank cell on the example, say P7. In this cell, we will expose the number of available troops in cells H14 through H16. We can click Formulas, Insert Function. I'm going to scroll down to PSI Dimension and then highlight PSI Data Source and click OK. The Function Arguments dialog opens displaying 5 arguments: SRC name, data IDX1 name, and IDX1 element for element. The first argument, SRC name, names the text file created by the extension, which is submitted along with the RACON model to the RACON server. For this example, I'm going to type available SRC. For the data name argument, the available data in Tableau must be mapped to the data source we create in the Excel workbook. The data_name field provides the name of the data repository that will appear in Tableau. For this function, I'm going to type available troops. It's very important to remember that the names we pass here are case sensitive. For the next argument, data, we're going to enter the Excel range where the data is located on the spreadsheet. I'm going to use my mouse to click the upward pointing arrow, and then I'm going to select cells H14 through H16. These are the cells containing the number of troops available to move. Notice that when these cells are entered into the dialog, the Excel-defined name troops underscore available appears. For the IDX1 underscore name argument, I'm going to enter the name of the first index set for the data specified and the data argument. I'm going to enter camps, which is the name of the first index set, the row-wise index set. They're right here in cells B14 through B16. Note that the row-wise portion of the index set must always be entered first. So if we were entering a two-dimensional index set, for example, the moving cost per soldier, we would enter the camps dimension first and then the bases dimension second. For the last argument, IDX1 underscore ELEM, I'm going to enter the Excel range containing the data or the elements for the first index set camps. And those are in cells B14 through B16. Since this index set is one-dimensional, nothing further is needed, and I can click OK to enter the PSI data source function into cell P7. Afterwards, we see that cell P7 displays the value given to the source underscore name argument. In cell P8, I'm going to add a second PSI data source function to expose the number of troops required per base. So I'll click Insert Function. PSI dimension is already selected, so I'll select PSI data source and click OK. For source name, I will enter required underscore source. This is the name of the text file created by the custom visual, which will be submitted along with the RACON model to the RACON server. For data name, I will enter required troops. This is the name of the data repository that will appear for this data in Tableau. Remember, names passed to this field are case sensitive. For the data range, I'm going to enter cells C18 through F18, or the number of troops required per base. This is the data associated with required troops. For IDX1 underscore name, I'll enter bases. This is the name of the index set that is associated with this data. And for IDX1 underscore ELEM, I'll enter the Excel range containing the data for the first index set, which is C13 through F13. Since this index set is also one-dimensional, nothing further is needed, and I can click OK to enter the PSI data source function into cell P8. So now we have two PSI data source functions. Finally, in cell P9, I will expose the moving costs per soldier according to the base and camp dimensions. This is a two-dimensional index set. I'll click Insert Function, PSI data source. For SRC name, I'll enter cost underscore SRC. For data name, I'm going to enter cost. For data, I will enter cells C8 through F10. These are the moving costs per soldier. The first dimension I will enter is the camp dimension. This is the row-wise dimension. For IDX ELEM, enter cells B14 through B16. Note that we are using the same row-wise data as we used for the first PSI data source function. It is very important when entering PSI data source functions to reuse the same index set names wherever appropriate. For the second index set, I'm going to enter bases, and I will enter cells C13 through F13. Now I can click OK. And now we have three PSI data source functions. Now real quick, I'd just like to point out in the PSI data source function in cell P9, I am using camps and bases. The first index set is camps, the second index set is bases. If I go to the PSI data source function in P7, I see that I've reused camps in B14 through B16. See, we have camps in B14 through B16 here. And then I also used bases in the PSI data source function in P8, bases in C13 through F13. And if we compare, we see bases in C13 through F13. Again, wherever it's appropriate, you should reuse the same index sets. Now we are ready to create the Tableau extension. First, I'm going to save the workbook, and then I'm going to select Analytics Solver, Create App, Tableau. Since this is the first time we are creating an extension from this model, there is no need to solve the model first. If, however, we make a change to the Troupe rotation model, then we would need to either diagnose or solve the model first to ensure that the changes are captured in the new extension. Immediately we see that the Save As dialog appears. I'm going to select a folder to save the extension. And then I'll click Select Folder. And here we see that the Tableau extension was successfully created, and indeed we will use version 2018.2 or later of Tableau. So I can click OK. At this point, our Excel model has been translated into the RACON modeling language, and our Tableau extension has been created. Open File Explorer and browse to the folder where you saved the Tableau extension. Within this folder, we see an extensions folder. And within the extensions folder, we see a solver.trex file. I'm going to open up this file using Notepad. This file contains information such as the extension's name, or how it will appear in Tableau, and the URL where the extension is hosted. To publish the HTML file to a website, simply replace http localhost:8000 with the desired URL. Since Tableau extensions are simply web pages, we will first need to start up a web server to serve our content. For this example, we will serve up the web page to the default location. To do so, I'm going to open a command prompt. I'm going to navigate to the root of the extensions repository. And then I'll run http server/p 8000. This command starts up a simple HTTP server listening on port 8000. Let's click back to Excel. In order to provide the data for the Troupe rotation example file to Tableau, we must create a data file. Within this file, we will pass the base and camp data. This data file can be of any format supported by Tableau, such as a CSV file, a text file, a database, etc. For this example, I'm going to use an Excel workbook to hold the data. For more information on the types of files supported by Tableau, please see the Tableau documentation at the website found on screen. I'm going to open a new Excel workbook. And within this new workbook, I'm going to create a table. Insert table. And my table will have headers. I'm going to have 13 rows and 5 columns. Now I'll enter our data. Now I need to put in my column headings. Note that each column heading matches the index sets used in the PSI data source functions: camps, bases, cost, required troops, and available troops. I'm going to click File, Save As, save this in my extensions folder as Troupe Movement Data. Now we'll open Tableau to import the new extension and the data. I'm going to connect to a Microsoft Excel file, so I'll click Connect to a File, Microsoft Excel, and select Troupe Movement Data and click Open. Sheet 1 appears under Sheets, and the data from that sheet appears at the bottom of the Tableau window. Now I'll click Sheet 1 within Tableau. Under Dimensions, I'm going to drag bases to columns and camps to rows. Under Measures, I'm going to drag cost to the elements of the matrix. I'm going to click the down arrow next to Sum and select Dimension. I'll rename this sheet to Cost and add a new worksheet. Here, I'll drag bases to columns and required troops as the elements. Again, I'll click the down arrow and select Dimension. I'm going to rename this sheet as required troops. Then I'll select a new worksheet. Here, I'm going to select camps to rows and available troops as the elements. Again, I'll select Dimension. Finally, I'll rename this sheet to available troops. Now I'm ready to create a new dashboard. I'm going to drag each of the 3 sheets, cost, required troops, and available troops, onto the dashboard. And then I'm going to click Extension at the bottom under Objects and also move it to the dashboard. I'm going to choose an extension. So I'll browse to where I saved my extension, click Select and click Open. And now I need to select my data. So to select a data source for camps, I'm going to select Available Troops, Camps. To select the data source for troops available, I'll select Available Troops, click OK. For bases, I'll select Required Troops, Bases, click OK. And then required troops, click OK. For cost, I'll select the cost sheet and select cost and say OK. The resultant Tableau extension is shown on screen. Here you see at the bottom that solver found a solution. All constraints and optimality conditions are satisfied. Here are the variable values and the constraints in the final solution. Here's the same extension with a redrawn dashboard. Note that each time you redraw the extension or rearrange the dashboard, you will need to match up your data sources. This ends our video on how to create a custom Tableau extension to solve an optimization or a simulation model within Tableau without the need to ever go back to the Excel model.